What's the connection between multiplication and the distributive property? We're going to take a look at the standard algorithm for double-digit multiplication. Let's say we're going to multiply two-digit number by a two-digit number, say 12 times 13. Let's set it up like we would normally solve a double-digit multiplication problem. So when you multiply the 2 in the ones place from the 12 and the 3 in the ones place from the 13, you get 2 times 3 equals 6. So I put the 6 in the ones place. Now we'll multiply the 1 in the tens place from the 12 and the 3 in the ones place from the 13. Remember, this is 1 is really a 10. So we get 1 times 3, which is really 10 times 3, and we get 3 in the tens place below. Our first line of the algorithm now has 36, and we'll move to the tens column to continue multiplying the rest. Now we're going to multiply the 2 from the ones place from the number 12 times the 1 in the tens place from the 13, which is really 10, or 10 times 2, so we get 20. And there's no 1, so we put the entire 20 down on the line below the 36. Now we're going to move over to the tens place for each the 12 and the 13 and multiply the ones times the 1, which is really 10 times 10. We get 100 as a product, and that will be a 1 in the hundreds place, leaving our second line as 120. We add the two numbers, 36 and 120, together, and we get a total of 156. 12 times 13 is equal to 156. This is what we call the American Standard Algorithm for multiplication. We're all familiar with this, right? Now, let's see how that shortcut was initially meant to be taught. The algorithm should first be taught by showing that each of the numbers must be multiplied by each of the other numbers, which would mean that we multiply the ones places together and we get 2 times 3, or 6 in the ones place. Then the 10 from the tens place and the number 12 is going to be multiplied by the 3 in the ones place from the 13, and this gives us 10 times 3, so we write down 30. We continue to multiply each number times the other. This brings us to the 2 times the 10, the 2 from the 12, and the 10 from the 13, giving us a product of 20. So we jot that down. Now we move to the last two numbers that need to be multiplied together. The tens from each of the two numbers, 10 times 10, and we have a product of 100. All of the partial products are added up for the product of 12 times 13, which is 156. What happens in the standard algorithm we are looking at in the very first slide? It's simply a shortcut making it faster to multiply, but most of us have never seen where this step-by-step comes from. So how does this connect to the distributive property? Did you see the partial products? Did you see the distributive property taking place here in this demonstration of multiplying with partial products? So let's take a look at the distributive property in action. Do you agree that we can say that 12 times 13 is 12 is equal to 10 plus 2 and 13 is equal to 10 plus 3? So if we have the same problem multiplying 12 times 13, we should be able to decompose these two numbers and write these two numbers as 10 plus 2 and 10 plus 3. By using the parentheses, we are able to show multiplication of the two by writing the quantity 10 plus 2 times the quantity 10 plus 3. Do you agree? Is it the same? Yes, it's the same. This is the distributive property. Does writing these two numbers in this way look like something you have seen in algebra? Do you recognize this from algebra? In algebra, we call this process of distributing the multiplication across each number the distributive property. In algebra, we use the acronym FOIL, which stands for firsts, outsides, insides, lasts. And the process of multiplying each of the numbers by each of the other numbers. Do you remember seeing this in the second slide where we discussed partial products? So you will see how each of the parts are multiplied by each of the other parts. For example, the first value in each parentheses is multiplied together, which would be 10 times 10, which equals 100. And this is the F in FOIL. Then we move to the O in FOIL, which is the outsides, and in this case, we will multiply the 10 times the 3, which equals 30. Now we move to the I for FOIL, and we multiply the 2 times the other 10, which equals 20. And lastly, we multiply the last number from each set of parentheses for the L in FOIL, 2 times 3, which equals 6. We add all of the partial products up. We get a total product for 12 times 13 as 156. Do you see this connection to the standard algorithm? Now, let's see what this would look like if we were to substitute in a variable and make it look a little more like algebra. So we have the quantity x plus 2 times the quantity x plus 3. Using this FOIL, our first product is x squared. The outsides product is 3x, and the insides product is 2x, and the last product is 2 times 3. When we combine or add this all together, like we did with the numerical values in our partial products, we end up with x squared plus 5x plus 6. We now have seen the connection between the distributive property and the standard algorithm for multiplication.